All right, everybody. So make sure you go ahead and update your table of contents. Today is the 7th. Intro to Exponents / product rule is our title. Put that at the top of your notes if you're not going to have a table of contents, remember. So for the warm up, go ahead and come up with 2 to the 3rd power equals and what 2 to the 5th power equals. So I get 2 to the 3rd power is 8, and 2 to the 5th power is 32. So what is it that exactly we're going to be talking about today? We're going to be going over exponents and introducing what exponents are and applying them whenever we have variables. So first off, we need to go ahead and get our definitions. So definitions, I can get them to work. There we go. All right, so base. Base is the number that needs to be multiplied repeatedly. So in this case, A would represent my base. Exponent, power, that's the number of times the base needs to be multiplied. So N in this case would be my exponent. Make sure you get both of those definitions down along with our diagram there with what A to the N is. All right, so take a minute, go ahead and evaluate all of these. Pause the video to do that. So here's what you should have got for the first three is 729, negative 729, and 16. Notice these first two are different answers because here, this first one here has parentheses where the second one does not. So what this first one is doing is it's saying take -3 and multiply it by itself 6 times. However, what the second one is saying is it's saying multiply 3 by itself 6 times. And then whatever you get, it's going to be a negative number. So that's the difference between that first one and second one. Let's go ahead and take care of the last three if we haven't already. So we should have got 625, 1 over 125, and 18. Okay, let's continue. All right, so let's evaluate these expressions below. We want to find out what each of these is equal to. Well, that first one is all numbers. So if it was my choice, I would just type that in my calculator, 2 squared times 2 to the 4th. And I get 64. Now, the reason for that we're getting 64 is that first pair is saying 2 times 2, while the second one is saying, now multiply that by another 4 2s. 1, 2, 3, 4. And if I do that in my calculator, I see 2 times 2 times 2 times 2 times 2 times 2 is still 64. Now, for number 2 here, I have x3 times x5 times x2. That I can't really put in my calculator because they're all x's. But could I do exactly what I just did there with the 2 where I spread it out? Yes, I could. So x3, I have 1, 2, 3 x's. Here, I have 5 x's. On the last one, I have 2 x's. When I am simplifying these laws of exponents, all I need to do when I'm seeing they're multiplying is just add up the number of x's I have. Count how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means my answer for that one is x to the 10th. So let's try this again now. On this next one, I see I have a combination of 5s and a's. Well, that first part is 5 times 5 times 5. Then I have a times a times a. I have another 2 5s. And then the last one, I have another 2 a's. Well, how many 5s do I have? 5 to the 5th. How many a's do I have? A to the 5th. Well, that 5 to the 5th, I can simplify because that is a number. 5 to the 5th is 3,125. A to the 5th, and that would be my answer. Let's try the next one. Pause the video to see if you can do it. So I have 3 G's. I have 5 H's, and then I have another G. So how many G's do I have? 4. How many H's do I have? 5. Final answer. So with all of that, hopefully you are noticing a pattern. If I went back to the 2 that we just did, if I looked at my G's, I had 3 G's and I had 1 G's. When I counted them up, all I'm really doing is adding the exponents, 3 plus 1, and I got 4. On number 3 here, I had A3 and A2. If I added 3 plus 2, that's how I can get A5. Same thing up here, 5, 3 times 5, 2 is 5, 5. If I go back one more, my x's here. If I did 3 plus 5 plus 2, I can get that 10 that I just got here. So we have a rule for this. It's called our product of powers rule, and you want to write this down. Whenever you have the same base, in this case, A is my base, I'm going to take whatever my exponents are, and I can add them to get my answer. So that's what you want to go ahead and write down. Whenever our bases are the same and we're multiplying, we can add our exponents. So let's try that on this next example. So on number 5 here, I have A, B squared, G3H times B3, G2H. What I would do is I would still break it down like we were doing before, but I don't have to spread everything out. Start with my A's. I have an A here. Do I have any more A's? No. B squared. Do I have any more B's? Yes. I have B3. G3. Do I have another G? Yes, I do. H. And I still have another H. Did I get all my letters? Yes, I did. So A, I still have A. B, when I add the exponents, I get B5. G's, I get G5. H's, I get H2. The only thing I need to do at the end is put all these letters together. A, B5, G5, H2 as my final answer. So let's try the next one. The next one, I see I have -3. What's in common with -3? It would be 5. Constants, coefficients, those go together. Put your coefficients together and multiply those, just like we're going to do with our A's. A2 and A. B3, B4. See what each of these equal. Through -3 times 5 is -15. A2 times A is A3. B3 times B4 is B7. So what's my final answer? Negative 15, A3, B7. All right, guys, if you want to see more examples, I will have a second video up. If not, then go work on your check for understanding for today.